Semiconductor manufacturing is highly complex, and quality control is a critical aspect of the production process. Wide bandgap semiconductors are essential for innovation. However, their manufacturing, research, and development processes require a new approach in metrology. We at Semilab develop metrology solutions for semiconductor device manufacturers in both the inline and R&D segments. Semilab's metrology solutions play a vital role in the wide bandgap materials market when it comes to measuring optical and electrical properties. During the manufacture of silicon carbide-based power devices, various properties should be measured during the quality assurance process: defects, dislocations and crystal inhomogeneities, depth and concentration profiling, electrical properties, as well as layer thickness and surface roughness. To measure the wide range of quality parameters of semiconductor wafers, there are four metrology categories: optical metrologies, non-contact electrical metrologies, contact or destructive electrical metrologies, and scanning probe microscopy can all identify industry-specific technological challenges. Contactless metrologies are critical for compound semiconductor characterization. Dopant depth profile, residual charge, dielectric characterization, carrier lifetime and resistivity of silicon carbide wafers can be measured using non-contact electrical metrologies. Resistivity is an important characteristic of semiconductor materials that quantifies charge carriers' ability to travel along thin film. The non-contact eddy current measurement technology can monitor the resistivity of bulk SiC wafers, which provides information for substrate manufacturers about the uniformity of the doping density. Semilab's RT2201E metrology system is ideal for this purpose. Monitoring lifetime is an excellent method to detect contamination. Semilab's WT systems help detecting metal contamination or crystal growth-originated defects by mu-PCD measurement. Non-contact mu-PCD measurement is based on the excess carrier generation by a laser pulse, which affects the change in conductivity and thus, microwave reflectivity. Knowing the uniformity of resistivity and mobility values are critical to achieve process optimization. Resistivity measurement for semi-insulator substrates can be measured with Semilab's COREMA 2000 system, which provides a contactless metrology solution for capacitance-based resistivity mapping of various compound materials. If you'd like to learn more about us, please visit our website at www.semilab.com.